In this section, we're going to talk about finding expected value, which is the idea of an average. But before we can do that, we need to talk about the setup of these types of problems. So these problems come from discrete random variables, which I know is a lot of terminology that we haven't talked about at all this term. So discrete is a way of saying kind of separate. We're going to have these separate outcomes. In fact, if we jump down to this example, we're going to look at a cafe, and they recorded some data in terms of number of cups of coffee sold in a day. So what we're seeing here is that on some days they sold 30 cups, 36 cups, 42 cups, 48, or 60. And we're going to limit ourselves in just saying those are the only outcomes they saw. Nothing else happened in between. So this is where it's discrete in that on a given day, we would see one of these 5 outcomes. We wouldn't see anything else. We're not seeing values that go to decimal places. We have these separate whole number outcomes that could occur. So that's where discrete comes in. And then we're going to use this wording for random variable, which the random variable will be represented by the letter X. And that's going to have various outcomes, and these discrete outcomes are coming from what occurs when we take this sample. So in the example we're looking at here, the number of cups of coffee sold, that's what X would represent in this case. In fact, we could even use this wording that X is the number of cups of coffee sold in a day. That's exactly what X would represent in this example. And from that, what we're going to have are these probabilities attached to each of these random variables. So with this random variable and having these possible discrete outcomes, we're going to have this row that's a bunch of probabilities of that value of X. So this table that we're seeing down below here, this is a probability distribution model or table. There's a few different phrasings for this, but probability distribution, let's just leave it at that. And it's a table that combines 2 pieces. It shows the possible outcomes for your random variable, and something that's going to be key is that it should show all possible outcomes, and then also the attached probability. So how I could read this table is that a cafe sells 30 cups of coffee in a day, 5% of the time. So the probability is showing how often that random variable occurs. And then for that cafe, 36 cups of coffee are sold in a day, 20% of the time. 42 cups, 25% of the time. 48 cups, 15% of the time. 60 cups, 35% of the time. So what this does is that then when presenting this information, if the cafe is just reporting that, oh yeah, selling cups of coffee in a day, we could see 30, 36, 42, 48, or 60. That is valuable information. You get an idea of how many cups of coffee are sold in a day there, but the probability adds so much more information, because what could happen is then we could say, okay, so they sell 60 cups of coffee in a day sometimes, but then what we could see is actually it's a pretty high percentage of the time that that outcome occurs, with 35% chance. And then where they list 30 as a possible outcome, if you just list those together, it sounds like they have kind of an equal probability of occurring. But then if you attach the probability, we could say, okay, 30 happens, but only 5% of the time. So it doesn't hold as much weight in terms of what we expect to happen. So what we want to end up doing is finding our expected value. If I wanted to know this expected number of cups of coffee sold in a day, I want to think about an average of those values. And part of that will be taking into account the probabilities. So before we get to actually finding expected value, let's talk about probability questions that we could answer with this table. So like I was saying, when they list out the values for the random variable, they should list out everything. So a property you should have when you get this table out is you should have this row of probabilities. They should all follow the rules of probability. They should all be between 0 and 1. And since we're covering our sample space here, when you take those probabilities, they should add up to 1. to exactly 1 to represent 100% of our sample space. So if you're given a table with missing information, or if they want to know if the table represents a probability distribution, that's a property that you would use, that the value should add up to 1, and then keeping in mind that the probabilities should be between 0 and 1. So what is the probability the cafe sold 36 cups of coffee? So in terms of notation for probability here, I'm just going to write this as what's the probability? Our random variable is 36. And from this, we would just go to the table and look up 36 cups of coffee, and that lines up with the 0.2. So this means there is a 20% chance the cafe sold 36 cups of coffee in a day. With part B here, what's the probability the cafe sold 36 or 48 cups of coffee? So when we have or, that's addition. So what we're going to do is take the probability of 36 plus the probability of 48. So take the 0.2 plus the 0.15, so 0.35. So there is a 35% chance the cafe sold 36 or 48 cups of coffee in a day. What's the probability the cafe sold at least 48 cups of coffee? So when we have probabilities, this wording of at least is important, and it's going to line up with the idea of more than or equal to. So imagine I said something like, today I'm going to eat at least 5 cookies. What you would think with that is that I'm starting with 5 cookies, and then I could eat as much as I want beyond that as well. So I could have 5, 6, 7, 8, 9, 100, anything at 5 or above. So it's a common mistake to switch this around by accident. Just think at least they're telling you the least value that you want. So we want 48 to be the smallest value, so we want this probability of being more than or equal to 48. So with that, what we would do is going to our table, we'd start at 48, and then we would just start adding the probabilities that fit above as well. So this will be the addition of 0.15 plus 0.35, which will be 0.5. So there is a 50% chance the cafe sold at least 48 cups of coffee in a day. Similarly, with wording that says at most, this is where they're telling you the largest value. So if I said today I'm going to eat at most 5 cookies, I'm limiting myself. 5 is the maximum. I could have anything less than, and that would be okay as well. So this is the equivalent of less than or equal to. So with that, finding the probability of x being less than or equal to 36, so what we're going to do is add up the probabilities that are at 36 or lower. So we're going to take the 20 plus the 5%, which is a 0.25. So there is a 25% chance the cafe sold at most 36 cups of coffee. So that's how we can find probabilities with this table, either just looking up a direct probability or adding a couple to match the wording of the question. Then what we might want to know is how many cups of coffee can they expect to sell on average? On a given day, what can we expect to occur for them? So this wording of expected, that's going to tie closely with our idea of average or mean. So when we do this, it's going to operate a little differently than how we found means previously, because now we have these probabilities. Like I was saying before, if 30 is only occurring 5% of the time, we don't want that to hold much weight in terms of the average, because it has a low probability of happening. And then 60, which has a 35% chance of occurring, we want to give that more weight because it happens more of the time. So this idea of expected value, we're going to answer this question in the next video and talk about how to find means with these discrete random variables with their probabilities.